This conference will now be recorded.
Good morning, all. Welcome to my session. So today, this is MySQL 8 tutorial day 5 session, and this is my information. And today, again, I will call MySQL 8 architecture because it is too much. So I'm explaining everything about architecture in terms. And today we will see how MySQL stores metadata. So metadata is basically information which is about the databases and whatever you are doing in the database that will store in terms of data dictionary. So that I will talk about. So the first thing is that data dictionary. So metadata is information, the data is stored in RDBMS, when you are creating a table or when you are altering the table columns, so all the definitions related to that, it will store in the database. So that is called as metadata. And about index and constraint definitions, that is also called comes in the terms of metadata. So data dictionary stores metadata in an RDBMS, and the metadata is information about the data that the database stores and includes things like column definition, foreign key constraint, index definition, table definition, and so on. So data dictionary is a collection of all these data for the database or for the RDBMS. And if you are giving creating a user and giving privileges, so that also store in RDBMS in metadata section. So this is all about metadata, just like as Oracle data dictionary. Now, what are the types of metadata? So when you create a database object, its metadata is stored in the data dictionary. Suppose if you create a table, then information about its column, indexes, and so on is stored. If you create a stored procedure, then the data dictionary store metadata such as invokers and privileges in the access control list. Okay, so see the figure. We have table definition, we have ACL, we have view definition, we have SP definition, we have schemas. Okay, so these are the types of metadata. Data dictionary in earlier version, how it looked like. So earlier it was file system, then system table, and then InnoDB system table. As I said, we have many storage engine, and so in that InnoDB and MySAM is popular, and InnoDB is by default that I covered in previous section. So before MySQL 8, the data dictionary stored metadata in different location. For example, .frm files for table definition, .opt files for database, .par files for partitioning, .trg and .trn files for triggers, and so on. Okay, we are all stored in the host file system. And even events stored procedure, the user tables and access control information were stored in a non-transactional MySAM tables, and InnoDB also maintain its own metadata. Okay, so this actually led to inconsistencies, issues with replication, and the data that was not uh, crash safe. Okay, so that's why MySQL decided in version 8 data dictionary look like this. We have InnoDB tables, and that is stored in InnoDB storage. So in MySQL, all metadata is stored in InnoDB InnoDB tables. There are no .frm, .opt, or other metadata files in the file system, and no reliance on MySQL, which is non-transactional storage engine. Okay, so this is the change, biggest change in MySQL 8. Now, what is transactional data dictionary features? With the some of information underscore schema tables are implemented as a view on the data dictionary table. So you can query the information underscore schema tables to view the database metadata information about the MySQL server, such as the name of the database or table or the data type of a column or access privileges. Okay, so it gives better performance, and it is easy to maintain, and atomic DDL and crash safe is the feature of InnoDB, and based on standard SQL definition, you have easier to extend common data dictionary API and automatic upgrade by using the installer, and single repository metadata repository for all MySQL Server subsystem. So all storage engine have their own user table, but all their metadata are stored in the same data dictionary table, and the data is table the table reside in the DB data dictionary table space. So that is the features of that. Now come to serialization of the data dictionary. So we know that every time there is a change to the metadata, MySQL creates a copy of it, and the metadata is serialized in JSON format, and it is known as SDI, serialized data dictionary information. And MySQL stores the copy. So if it is InnoDB, so in InnoDB, in the InnoDB user is a table space along with the data. And if your storage engine is my is AM, and then there is a file extension .sdi in the database directory. So you can find out with the help of extension. Okay. Because why I am telling this, because if you don't know about these things, so how you can manage the metadata and how you can manage the user data, because you don't know where actually your user data is stored. So MySQL 8 provides crash safety by serializing the metadata whenever it changes. So the output of this is in JSON, that is JavaScript object notation format. And for InnoDB table, this SDI is stored with the data in the InnoDB user table space. And the SDI is just a backup of the metadata. It is not the metadata itself. And the data dictionary lives entirely within the InnoDB data dictionary table space. Okay. Now, dictionary object cache. So what is all about? It is a shared global cache that store previously accessed data dictionary objects in memory to enable object reuse and minimize disk I/O. So uses it will use or it is using LRU based eviction strategy that is same as in the Oracle, and whatever the objects are not using, it will flush out. And it comprises cache partition that is stored different object types. So if you see that cache partition section, we have table definition, we have a schema, we have table space definition, schema definition, table definition, stored program, definition, character set definition, and collation definition, cache partition. And the limit is 256, 256, 151, 256, 256, 256, like that. Okay, and what are the variables to configure the limit? So these are the variables which you can check in the database. That is table space definition cache, schema definition cache, max connection stored program definition cache. Now come to InnoDB table space. So in this, we will see what are the table space we have for this storage engine. So InnoDB table space are data files that can store one or more InnoDB tables and associated indexes. And we have following types: data table space, undo table space, temporary table space. So in data table space, we have system table space, we have file per table space, we have general table spaces. Okay. So first, InnoDB system table space. So InnoDB system table space basically consists of change buffer and a double write buffer and possibly table index data of user defined tables. So what is change buffer? Whatever changes to secondary index pages that comes in this section. And what is a double write buffer? Ensures cache crash safe write. So that's why that is there. And it is strongly recommended to store the table data in file per table space or journal table space instead of the system table space for easier maintenance. Same as Oracle system table space and SysOp. We didn't store user data. We have users table space in Oracle and index table space for index. So like that, here also the same concept. And by InnoDB data file path option. By that, you can configure the size and physical location of the InnoDB system table space. And default value is 12 M auto extend. And two files like we have IB data1, IB data2, like this. And you have set of files in the system table space. Only the last file in the set can be auto extending. So this is important point. And the file can grow but does not shrink. So please remember that. And what is the extension of this? .ibd file. Okay. Now come to file per table space. So as I said, it contains data and index from a single table, including its metadata. And extension is .ibd files named for the table in the database directory. So how you can create table, table name, then A integer primary key, B character key. So it will create the fpt table.ibd file in the current database directory. And if you want to use explicitly table space clause, so you have to mention table space equals to InnoDB file per table. Okay, so that is, and creates a file per table space even if InnoDB file per table is off. Okay, if you are explicitly giving that. Now, general table space, InnoDB support only one data file per table space. So that is important point. You cannot add a second data file to an existing general table space. So as I said, it contains data and index for multiple tables and .ibd files named when you create the tables and do not belong to any particular database. So how you can create that? Create table space, table space name, add data file name. And if you want to place a new table in general table space by specifying a table clause, so in that you have to mention the general table space name by table space equals to, and you can move a table to general table space with alter table option. So you have these options when you are creating a table. Now choosing between a file per table and a general table space. So per table space it has some benefit. General table space have some benefits. What are those? In per table space, table compression, space reclamation, and you cannot mix compressed and uncompressed table within the same general or system table space. And space reclamation, you can use truncate. So InnoDB drops and recreates truncated file per table space and release free space back to the file system. And if you are using general table space, it has less file system overhead for statement that remove large amount of data. So you can use drop table or truncate table, and it consume less memory to store table space metadata. So if you can mix table space types within a database, so some table you can store in file per table, some table space you can store in general table spaces. So multiple general table spaces you can also use. So like that you can manage your MySQL database. And next thing, locating table space outside the data directory. So InnoDB underscore directories may be specified as an option in a startup command or in a MySQL option file. So restart is required to change the value. So directory is defined by InnoDB data home underscore dir or InnoDB underscore undo underscore directory, and data dir are automatically appended to the InnoDB underscore directories argument value, regardless of whether the InnoDB underscore directories option is specified explicitly. So physically separate data set from other data and place same data on faster device than general data. So how you can do that? You can use the data directory clause, and if you are creating a table space, you can go give relative or absolute path. And relative path use the data directory as their root, and absolute path can refer to any file system target. So that directory must be specified in the read-only variable, that is InnoDB underscore directories, as I said. And also the directories specified by this variable are also used for table space discovery during crash recovery. Now come to the last table space, that is temporary table space. So InnoDB has two types of temporary table space. One is session temporary table spaces. Second is global temporary table spaces. So the maximum of two table spaces is allocated to a session. One is used for user created temporary table space, and the other for internal temporary tables created by the optimizer. So when a session disconnect, its temporary table spaces are truncated and released back to the pool. So that is important thing. And each table space is stored as a file with extension. The file extension is .ibt in the directory specified by the InnoDB underscore temp underscore table spaces underscore dir variable. So the default location is the InnoDB underscore temp directory in the data directory, and the information underscore schema dot InnoDB underscore session underscore temp underscore table spaces table provides metadata about session temporary table spaces, and information underscore schema dot InnoDB underscore temp underscore table underscore info table provides metadata about user created temporary tables that are active in InnoDB instance. So this is about the things which is related to temporary table space. And in slide, you can see a pool of 10 temporary table spaces is created when the server is started, and the size of the pool never shrinks, and table spaces are added to the pool automatically as necessary. And if you are allocating to a session from a pool of temporary table spaces on the first request to create an on disk temporary table, and in global rollback segment, suppose undo logs for changes made to user created temporary tables are there. And the relative path, I already told that InnoDB temp data file path, and if no value set, all temporary table spaces or files are created in a 12 MB or to extend data file called IB temp1, okay, TMP, in the InnoDB data home dir directory. So this is about the some point which is related to temporary table space. I hope it is clear till now. Okay, so that's it all about in MySQL architecture. And the last lecture which comes, I will cover about redo and undo logs, how MySQL uses memory and plugin and component interfaces. So these three topics I will cover in next session. So please join on next weekend on Saturday. And then after that, MySQL 8 architecture will finish. And if you have any doubt, anything, or you want to register, you can use these links, and you want to give feedback, you can use this.
This
And
conference will now be recorded.
you can write about the questions, or you have any doubt, you can mail to me. And so that's it for today. And good day, and enjoy the weekend.